So I realized we didn't actually cover direction angles, and so an example question would be find the direction angle for 2, 3, -4 and the x-axis. So usually the direction angles are alpha, beta, and gamma, and alpha is relative to the x, beta is relative to the y, gamma is relative to the z-axis. And so what it actually looks like is, so here it is in GeoGebra, what it actually looks like and what we need to find. And there is 2, 3, and -4. Now you see the z value is negative, and so it is it's actually underneath that plane. And when you look at it, you'll see you can actually make a right-angled triangle with the x-axis, with the base being the coordinate 2, and then there's our point, and it makes a nice right-angled triangle, and we need to find this angle between the hypotenuse and the x-axis. Now, it's not quite as simple as being a right-angled triangle because, as you can see, when we get the whole thing, when we get the whole thing spun back around, there we are. It's actually a little bit on an angle, but that's okay because it's still a right-angled triangle no matter how we want to talk about it, and all we have to do is find that angle. So we need to find the length of one side and the length of the hypotenuse. So that should be easy enough. The hypotenuse, well, the length of the side that runs along the x-axis, obviously, is just 2. And the length of the hypotenuse is actually just the length of the vector. And so I'm going to call this u. So the magnitude of u is the square root of 29. And so we know that cos theta is going to be 2 over the square root of 29. So theta, or I should actually call it alpha, because it's the angle between the axis, between the x-axis and that vector. Alpha is equal to the inverse cosine of 2 over root 29. And when I do the inverse cosine of 2 by square root of 29, I get 68 degrees. And if I actually take a look in GeoGebra, and I had cleverly measured this in advance, you maybe can't see it. But there's my angle right there, and it's 68 degrees. And so that is my alpha, my angle between the vector and the x-axis. To do the y-axis, all I have to do is use the y-coordinate and the hypotenuse, do the exact same thing. And for the z-coordinate, once again, I just have to use the z-coordinate and the z-coordinate and the hypotenuse to find the exact same thing. So that's finding those direction angles.